Hello, it's Mr. Norris. I just want to take a second to talk about general rules for different kinds of transformations. You may know how to go from a rule and create the transformation by drawing it. In other words, you may be given the rule and then you could go draw that on a graph. But I want to go in the opposite direction. I want us to be able to take a graph of some kind of picture, and out of that create some kind of general rule. Now, if you're unsure, let me tell you a little bit what I mean by general rule. In a general rule, we take some kind of point, x, comma, y, and we're able to send that to some new point, something, comma, something. So whatever point we put in, it gives out this new information. The question is what that general rule is going to be and how is it going to change depending upon the pictures that we're talking about. Let's take a look at this image for a second. So notice if I'm looking at A, that's simply an A. Whereas if I'm looking down here at this point, that's A prime. So the question is, which is our pre-image and which is our image? Because there's no prime sign by the points in this polygon, this is our pre-image. In other words, this is where we're starting. So let's just write that out. This is the pre-image. And of course, that means that our next polygon is going to be called the image. So what happens as we go from the pre-image to the image? Well, let's write out some points and see if we can figure it out. So let's write out A to start out with. I'm going to write out what A is. So A is going to be 1, 1. And it goes to 1, negative 1. In other words, this was our original point, and then it went to that new point. Okay, so now that we know that, let's try, we can't just go by one point. Excuse me, I should probably write an A prime here. Sorry about that. Let's go ahead and write an A prime here to indicate that our new point is 1, negative 1. Okay, sorry about that. Now let's talk about another point, and we can pick any that we want. It's not safe just to pick one point in the pre-image and one point of the image. We want to do several. Let's talk about maybe D. So D is going to be 3, 3. So let's write that out. D is 3, 3, and it goes to 3, negative 3. And again, I'm forgetting to write my prime, so I'm just going to put D prime to indicate that's what we're talking about. Alright, let's do one more. Maybe let's talk about the point F. So it looks like F is at 1, 2, 3, 4, 5, 6, 7, 1. So I'm going to write that out. F is 7, 1, and that's going to this new point, 7, negative 1. So that's F prime, and we're looking at 7, negative 1. So the whole point of trying to write out each of these individual points is to determine what our general rule is. So let's look at what's happening. X coordinate stays the same, 1 to 1, 3 to 3, 7 to 7. But what's actually changing in these ordered pairs? What's changing from here to here, or from here to here? What's actually happening is the y coordinate is flipping signs. So positive 1 becomes negative 1. Positive 3 becomes negative 3. Positive 1 becomes negative 1. So positive y becomes negative y. So let's go ahead and write that in. Negative y. We know that in each of our examples, 1 stayed 1, 3 stayed 3, 7 stayed 7. So we're talking about x staying the same as x. So our general rule for a transformation, a reflection across the x-axis is xy going to x negative y. Now that's not a rule that you have to memorize. Ideally, I should be able to give you some kind of image, and from that image, You can write out some examples of what happens to individual points and ultimately come up with a rule yourself. So don't think about memorizing this. I don't want you to think, hey, anytime I'm dealing with a reflection across the x-axis, this is the general rule. I want you to be able to understand how to go through these steps to get to that rule. So let's look at another kind of transformation. Here we looked at a reflection. In the next example, we're going to look at a translation. In this example, we're not turning the preimage, we're not flipping the preimage, we're simply shifting it. So this is our preimage, and we're shifting it in this direction, down towards our image. Let's see if we can determine a general rule for this kind of translation. So, like in our last example, we're just going to write out our points. So, maybe let's choose, and again, you can choose any points that you want. Let's go ahead and choose A and A prime. So I'm going to write that out. It looks like A is located at 1, 1, and what is that going to? Well, let's look down here. Looks like A is at 1, 2, 3, negative 3, comma 1, 2, 3, 4, 5. Looks like it goes to negative 3, comma 5. So let's go ahead and write that out. Going to negative 3, comma 5. Not too bad, so there's an example of our first point. Maybe now we could look at another point. Maybe we could look at point D going to point D. D going to D prime. So let's write that out. We have D. D is located at 3, comma 3. And it looks like the new D is going to be right here at negative 1, comma negative 3. So we're going to go ahead and write that out as D prime, and that's at negative 1, comma negative 3. I'm going to get one more example just to make sure I fully understand the rule. So let's go from F to F. So this F is located at 1, 2, 3, 4, 5, 6, 7, comma 1. So F is at 7, comma 1, but what is F prime? Let's go ahead and write that out. And sorry, I forgot my prime when I was putting D prime there. Okay, so what is our F prime? Well, it's going to be something, comma something. We're looking at 1, 2, 3 on our X, so I'm going to put that in. And I have 1, 2, 3, 4, 5, negative 5 on my Y, so I'm going to go ahead and put that in as well. So 3, comma, negative 5. So now that I have this information, I should be able to say X, comma, Y goes to something, comma, something. But I don't know what my rule is yet. Well, let's look at what happens in our picture for X. So right now, since I'm talking about X, I'm going to think about going left and right. So A, to get to A prime, had to go 1, 2, 3, 4 spaces to the left. If I'm looking at D, going to D prime, it had to go 1, 2, 3, 4 spaces to the left. And that's exactly the pattern that we see over with our ordered pairs that we have written out. We notice that 1 minus 4 gets us to negative 3. 3 minus 4 gets us to negative 1. 7 minus 4 gets us to 3. Therefore, X minus 4 would get us to simply X minus 4. Perfectly fine to write out your rule like that. Now let's go ahead and talk about what happens on our Y. What are we going to put into this space? So let's think again about what's actually happening on the picture. It looks like to go from C down to C prime, I had to go 1, 2, 3, 4, 5, 6 spaces. Same thing with A to A prime. I had to go 1, 2, 3, 4, 5, 6 spaces. Let's see if that holds true over here. So I have 1 minus 6, and that got me to negative 5. I really need to draw my negative in there where you can see it. Okay, and then I got 3 minus 6 got me to negative 3. 1 minus 6 got me to negative 5, so I can write the same thing here. Instead of y, for any y I put in, I'm going to write y minus 6. So this is our example of how to write out a general rule for a transformation. Specifically a translation. rotations are perhaps the most interesting kind of transformation that we can look at as far as writing out a general rule. So to begin with, sometimes I just like to go ahead and write out my answer, at least in its general format, even if it's not a complete final answer. So I know that I want x comma y to go to something, comma something. I'm just not sure what that is yet. Not too bad. So let's sort of just bridge this off, and let's start picking out some different kinds of points that we can look at. Okay, so let's look at Q1 for example. So Q1 is located at, I'm going to put Q, and that goes from 1, comma 1 all the way over here, 90 degrees, counterclockwise rotation, to negative 1, comma 1. So I'm going to write that out, negative 1, comma 1. Now it's not good enough, like I've said this whole time, it's really important to know this, it's not good enough to just tell your general rule from one specific point. We have to get typically around 2 or 3 to really see what's going on and be sure of ourselves. Alright, let's go from R to R. So a 90-degree rotation from R to R prime. Alright, so R is located at, let's see, 1, 2, 3, 4, and then 1, 2, 3, 4. So it goes from 4, comma 4 over to R prime, which is negative 4, comma 4. Alright, let's look at our final example. So let's write out S1. S is located at 1, 2, 3, 4, 5, 6, 7, comma 2. So S is at 7, comma 2. And that's going to go to S prime, which is going to be located at negative 2, comma 7. The reason why I really like this transformation, this kind of rotation that we're looking at, is that if we had just relied upon Q and R, we would think that the general rule might just be xy to negative x, comma y. Because really what we're looking at is 1 goes to negative 1, alright, 4 goes to negative 4, so x should go to negative x. But that's actually not the case. There's something else going on once we look down here at that final point that we're looking at. Not only do we have a switch from a positive sign to a negative sign, we also have a flip. So 7 was in the x place, well now 7's in the y place. Here 2 was in the y place, and now it's in the x space. So we have something more complicated than this rule that we originally thought. In reality, x and y flip, so for whatever point we put in, these two values are going to flip. So I'm going to have y here, and I'm going to have x there. And I also know that this is going to become negative, because I know that I went from 1 to negative 1, 4 to negative 4, and then 7 to negative 2. So I have positive to negative, positive to negative, positive to negative. That's why I had to go from a positive to negative in my general rule. Okay, so the purpose of this video was to go through several examples of coordinate images, looking at a coordinate plane, looking at rotations, translations, reflections, and being able to get a general rule based upon looking at those images.